The year is 1943. The war is at its most brutal turning point. On the Eastern Front, millions of men are locked in a death struggle across frozen plains. In the Pacific, island by island, the tide is slowly, painfully shifting. And in the skies over Europe, thousands of young men are dying every week in aircraft that, by the standards of what was secretly being developed just miles away, were already obsolete. Because while the world watched the known war unfold, another war was being fought in secret. A war of blueprints and wind tunnels, of prototype crashes and classified autopsies. A war where the prize wasn't a city or a coastline, but the future of flight itself. These were the aircraft no government wanted you to know about. Some of them never reached the battlefield in time. Some were canceled for reasons that had nothing to do with engineering. And some were so far ahead of their era that the world wouldn't fully understand them for another 50 years. This is the story of the most secret aircraft of World War II, the machines that didn't just fight the war, they invented tomorrow. We begin in Germany, and with the aircraft that more than any other announced that the age of the propeller was over. The Messerschmitt Me-262 had been in development since 1938, growing out of a German Air Ministry requirement for a jet-powered interceptor. But progress was agonizingly slow. Early jet engines were dangerously unreliable. The Junkers Jumo 004 turbojets that would eventually power the aircraft had a lifespan of barely 25 hours before catastrophic failure. Pilots called it the aircraft that wanted to kill you before the enemy could. And yet, when it flew, nothing in the world could touch it. The Me-262 reached operational speeds of 541 miles per hour. Compared to the 437 miles per hour top speed of America's best fighter, the P-51D Mustang, it climbed faster, it turned inside conventional pursuit curves, and its four 30mm cannons could tear apart a B-17 Flying Fortress with a single 2-second burst. Allied bomber crews began filing reports in late 1944 that described something impossible. A fighter with no propeller streaking through formation at unimaginable speed, firing and vanishing before the gunners could even track it. It came through the formation so fast I thought it was a rocket at first. No sound warning, just a flash, and then two of our guys were gone. The Allied response to the Me-262 was, at first, panic, and then adaptation. Pilots learned that the jet was most vulnerable during takeoff and landing, when its engines were slow to respond. American and British pilots began patrolling German airfields, a tactic known darkly as rat-catching, waiting for Me-262s to slow down on approach and then diving on them. But there was another enemy destroying the Me-262 from the inside: Adolf Hitler himself. In a catastrophic strategic blunder, Hitler became obsessed with using the jet as a high-speed bomber, not a fighter. He reportedly screamed at his generals that he wanted it to carry bombs over Allied positions, not intercept them. This single decision delayed the Me-262's combat deployment by an estimated 6 to 9 months, months that proved irreversible. By the time the program was allowed to operate as a fighter in numbers, over 1,400 Me-262s had been produced. But fuel shortages, Allied bombing of factories, and a collapsing Reich meant fewer than 300 ever flew in actual combat. The jet that could have turned the air war flew mostly on the ground, useless, waiting for fuel that never came. After Germany's surrender, Allied engineers descended on every Me-262 they could find. The aircraft was dissected, analyzed, and copied. American, British, Soviet, and even Japanese engineers all admitted the same thing. Germany had been years ahead of everyone else. In the United States, the revolution wasn't happening in a fighter cockpit. It was happening in a California desert, and it was being driven by one man's almost religious obsession. John Knutson, Jack Northrop, had been designing aircraft since the 1920s. But one idea consumed him above all others. The flying wing, an aircraft with no fuselage, no tail, no drag-inducing body, just one enormous, unbroken wing carrying everything inside itself. Engines, crew, payload, fuel, all buried within the wing's smooth, continuous surface. On paper, the advantages were staggering. A flying wing would generate far less aerodynamic drag than a conventional aircraft, meaning it could carry more weight, fly farther, and burn less fuel doing it. Northrop calculated that a flying wing bomber could potentially fly non-stop from the continental United States to targets in Europe, eliminating the need for forward air bases entirely. The U.S. Army Air Forces, under pressure to find an intercontinental bomber before the war ended, gave Northrop the green light. The YB-35 first flew in June 1946, just after the war's end. Its wingspan stretched 172 feet, wider than a modern Boeing 737. It was powered by 4 massive piston engines driving contra-rotating propellers, and its silhouette against the Mojave sky was unlike anything aviation had ever produced. It looked, as one test pilot put it, like something from a dream or a nightmare, depending on your seat. The follow-on YB-49, which replaced the piston engines with 8 jet turbines, flew in October 1947. And during early test flights, something unexpected happened. Ground-based radar had extraordinary difficulty tracking it. The smooth, continuous curves of the wing produced a radar reflection far smaller than its massive physical size suggested. Jack Northrop believed, and many historians agree, that the cancellation was driven by politics, not performance. He spent years trying to understand why. He never fully did. But in 1980, when he was 85 years old, confined to a wheelchair and largely forgotten by the aviation world, Air Force officials brought him to a restricted facility. They unveiled a scale model of a new classified bomber, one whose silhouette he recognized instantly. It was his flying wing, updated, perfected, reborn as the B-2 Spirit. Not every secret weapon was exotic. Some were revolutionary for a completely different reason. In 1938, a senior engineer at the de Havilland Aircraft Company named Jeffrey de Havilland walked into a Royal Air Force procurement meeting and proposed something that made the assembled officers visibly uncomfortable. He wanted to build a bomber out of wood. Not because wood was cheap, though it was. Not because Britain had a shortage of aluminum, though it did. But because de Havilland believed a wood-framed fabric and plywood aircraft, built light enough, could fly so fast that it would never need defensive guns, armor, or a fighter escort. The RAF turned him down. He built it anyway, using company funds. The de Havilland DH-98 Mosquito first flew in November 1940. Initial RAF test pilots filed reports that Air Ministry officials genuinely did not believe. The aircraft had reached 388 miles per hour in early trials, faster than the Supermarine Spitfire. In later marks, it would exceed 415 miles per hour. The ministry relented. Orders flooded in. On January 30th, 1943, the 10th anniversary of Hitler's rise to power, during a major Nazi propaganda broadcast from Berlin, Mosquitoes of the RAF appeared over the German capital in broad daylight and forced the speech to be delayed for over an hour. The symbolism was devastating. Later that year, in Operation Jericho, Mosquitoes flew at treetop level through occupied France to breach the walls of Amiens prison, freeing French resistance fighters condemned to execution with bomb runs accurate to within feet. And because the Mosquito was wood, bonded birch plywood, spruce spars, and balsa sandwich construction, it returned a radar echo far smaller than its actual size. German radar operators consistently misidentified it, miscalculated its speed, or lost it entirely. The wooden wonder was, without anyone fully intending it, an early stealth aircraft. Hermann Göring, upon learning that Britain was building high-performance warplanes out of timber while Germany's industrial machines strained to produce aluminum airframes, was reported to have broken into a rage, and then reportedly into tears. The British, he allegedly told his staff, can do in wood what we cannot do in metal. By 1943, America knew it was falling behind in jet technology. The Me-262's existence was an open secret among Allied intelligence analysts. Something had to be done, fast. The answer came from a 33-year-old engineer named Clarence Kelly Johnson at the Lockheed Aircraft Corporation. Johnson walked into a meeting with Army Air Force's brass and made a stunning promise. Give him a small, hand-picked team, no bureaucratic oversight, and complete secrecy, and he would deliver a flyable jet fighter prototype in 180 days. Johnson's team, operating out of a rented circus tent adjacent to a Burbank plastics factory, next to a Malodorus manufacturing plant, worked around the clock in conditions that oscillated between brilliant and chaotic. They called themselves Skunk Works, after the moonshine distillery in the Lil Abner comic strip. The XP-80 would arrive too late for World War II in significant numbers. Only 2 reached the European theater before Germany's surrender. But what Johnson built at Skunk Works was more important than any single aircraft. He built a method, a system for producing revolutionary aircraft in absolute secrecy, at impossible speed, with minimal bureaucracy. The Skunk Works program would go on to produce the U-2 spy plane, the SR-71 Blackbird, and eventually the F-117 Nighthawk, the world's first purpose-built stealth aircraft. Every classified aircraft program in American history since 1943 owes a debt to a circus tent in Burbank and a fast-talking engineer who was given 143 days and needed every single one. The Me-262 proved that jet propulsion wasn't a fantasy, it was the only future. Every commercial airliner in the sky today carries that legacy in its engines. The Horton HO-229 proved that shape was a weapon, that an aircraft could defeat radar not with speed or altitude, but with geometry. Every stealth aircraft in every Air Force on Earth carries that lesson in its angles and curves. The Mosquito proved that innovation doesn't always come from the expected direction, that sometimes the most radical idea is the simplest one. And Skunk Works proved that secrecy, when properly managed, isn't just a security measure. It's an accelerant. Remove the committees, trust the engineers, protect the work from interference, and human ingenuity moves faster than anyone thought possible. The men who designed these aircraft, Messerschmitt, Northrop, the Horton brothers, de Havilland, Kelly Johnson, were not just engineers. They were people who looked at the sky and saw something different from everyone else. Something that wasn't there yet. Something that should be there. They built it in secret. They flew it in secret. Many of them died before the world understood what they had done.